As we continue in section 1 here, I've got a couple of things that are just review. You guys have talked about right angles before, and these are angles that equal 90 degrees. And we're usually just got done talking about that little box notation in the corner. Acute angles are angles that measure less than 90 degrees. So they're somewhere between 0 and 90 degrees, and we see pictures of those. And then we've got obtuse angles, which are angles that are greater than 90 degrees. And those are terms that you've probably seen before. This angle might be, 120 degrees. A straight angle, aka line, might be something that you've never really thought about naming that way, and those always equal 180 degrees, especially if you think about it as a line, that this whole thing would be 180 degrees. Those terms are probably very familiar to you. These next terms are very crucial. We talk about these all the time, so these are really important vocabulary words. The word adjacent by itself means right next to. And when we talk about angles being adjacent, we're talking about having the same vertex and sharing a side, and they are non-overlapping. And this is going to create some really interesting opportunities to be able to solve problems. So in this picture, we see the shared vertex here, and we see this shared side. So we have this angle PQR, and we have its partner here, angle SQR. Notice how the vertex is in the middle, are adjacent. They share ray QR and they share vertex Q. Complementary is an important word, and you have to know that that means two angles that add 290. Okay, they may or may not be adjacent, not necessary. So here you can see that this angle and this angle happen to be adjacent. 40 plus 50 is 90. They are complementary. This angle and this angle are not adjacent, but 27 and 63 add together to 90, so that makes them complementary. So this is a way I could describe the relationship between two angles. Remember our second learning goal, we're going to move to problem solving. So I think you can anticipate how that might look. Supplementary, two angles which add to 180. Again, may or may not be adjacent. The main thing is that any two angles, like 40 and 140, add up to 180. 60 and 120 add up to 180. Situation of adjacent, not adjacent. Key theorems that we use a lot: linear pair and linear pair theorem. The minute I see linear pair is I see the words line pair. This is where we have two adjacent angles, which form a line. Two adjacent angles which form a line, which means they are supplementary. So that's what the linear pair theorem says, is that these two adjacent angles that make a line always add up to 180. So what I'm going to write is I'm going to write that angle MNP plus PNO will equal 180. Now, we really work hard in geometry to not assume things. We always want to be able to prove them from the notation, from the markings. Linear pair is one of the things that you can take from a picture. You can assume that if it looks like a straight line, it is a straight line. And so you're always able to write this equation. In the same way, vertical angles and vertical angle theorems. Vertical angle are two angles with the same vertex, but no common sides. So when we look at this picture, here's our vertex right here. 1 and 3 share the vertex, but they're not adjacent. Vertical angles cannot be adjacent. They go in opposite directions. The cool thing about vertical angles is they are equal. So angle 1 is equal to angle 3, and angle 2 is equal to angle 4. Again, if you have two intersecting lines, you will always have two pairs of vertical angles, and you can know that simply from the picture and be able to write those equations. So just to do a little review, if we look at this picture here, and we want to find a pair of vertical angles, there are many, but the first thing I look for is where do I perhaps have lines that intersect. When I look at those intersecting lines, I see I would have a pair of vertical angles there, and then I would have a pair here and here. And it's okay, I can ignore Ray and K to talk about the bigger angle. So a couple pair of vertical angles would be angle I, N, J would be equal to angle, so I said I, N, J, equal to angle M, N, L, or angle I, N, M would be equal to angle J, N, L. A set of linear pairs that exist in this picture. Again, I'm going to look for a line. This is where colored pencils are really nice. I look at this line right here, and I see this ray right here forms two angles. Those become my linear pairs. And so I would say angle JNI plus angle INM are equal to 180. And we're going to talk about giving reasons by linear pair theorem as we move on. I know that those two angles are going to add to 180 because they are linear pairs. Complementary, remember that's adding to 90. And the only way to know that angles add up to 90 if I don't have numbers on them is to look for a right angle box. So my complementary angles are angle I, N, J, and angle J, N, K. So you can write it that way, that those two are complementary, or you could write them in a number sentence, angle I, N, J plus angle J, N, K equals 90. Same way with supplementary, you're looking for basically lines. So we could use our same answer for our linear pairs, or if we want to look at another one, we could look at this line and we could look at this side. And I could talk about angle J, N, L. So J, N, L would be supplementary to angle L, N, M. This guy over here. L, N, M. And there are others. That's just one pair. Adjacent, lots of different potential answers here, and that's kind of the beauty of it. In geometry, there's often lots of answers. We could use our linear pair answer from here. We could use our complementary answer because those are adjacent. We could use our supplementary answer. And we could pick two that we don't even know what they add up to, but they simply share a side, like these two. So I could say angle JNK and angle KNL are adjacent. Just remember, with adjacent, we have no idea what the relationship, what they add up to. We just know they share a vertex, N, and they share this side right here, NK. So here's where we're going to get to the problem solving part of things. So, number one, read the problem. If angle GHI and JKL are complementary, what is the measure of each angle? So complementary is 90 degrees. So we always, in geometry, want to be going from words and pictures to equations. So we have this relationship of complementary. So GHI and JKL add up to 90. So let's go ahead and write that. How big? We can start here. Angle GHI plus angle JKL equal 90. That's the words to an equation. Well, now I have some expressions of how big these angles are. So I can replace those. I can say 8R plus 9. That's how big GHI is. And I'm going to add 7R plus 6. That's how big JKL is. And that equals 90. And now suddenly I'm back to an Algebra 1 problem that I can easily solve. So I'm going to go ahead and combine my like terms. 15R plus 15 equals 90. I'm going to subtract 15 from both sides, so I have 15R is equal to 75. Divide both sides by 15, and R is 5. Now in geometry, you always want to be sure you answer the question. And I want the measure of each angle, not R. So now I need to substitute R in there. I need to substitute R in there. And so if I say 8 times 5 plus 9, this angle is 49 degrees. If I do 7 times 5 plus 6, 35 plus 6, this is 41 degrees. And as a check, those two better add up to 90, and they do, so I know I did my problem right. So let's look at this example. What's the measure of angle STU? Well, first of all, I have to figure out where STU is. STU. So I'm looking at this angle. How is that angle related to anything else I know? Well, I know this angle right here. And these two angles share a vertex, but they don't share a side. And so this makes them vertical angles. So that means that angle STU is 18 degrees because vertical angles are equal. We have 2 more examples. Go ahead and tune into the last video for those last 2 examples.